Hi, hello, and welcome to the Physics Clinic. We'll move on to the next topic today. So it is all about inductive effect we are going to see. So right now, we'll see this electron movement in organic reaction. So it shows how the bonding is occur and then how the electron is redistributing during the reaction. So to show the change in position of a pair of electrons, this curved arrow, okay, it starts from the point from where an electron pair is shifted. It starts from the point here where an electron pair is shifted. Okay, so very important point. You can understand this. Here, it starts from the point where the electron pair is shifted. Okay, so this arrow mark. Then, and it ends at a location to which the pair of electron may move. Okay, so this is how the electron is moving. Okay, so from here, from pi bond to adjacent bond position, it is moving. Right? From pi bond to adjacent bond. So So here from pi bond to the adjacent bond position it moves. Okay. So what it is happening? Pi bond to adjacent bond position. Okay. Then from pi bond to adjacent atom here also, you can see this, right? So how the bond now it becomes here it forms single bond. Here again the bond is moved, right? Electron is shifted. So here right side it is double bond. Okay. So here also from the double bond to this particular atom it is not the adjacent position, it is adjacent atom. So that the bond is breaking and the electron pair is moved to the atom itself. Okay. So it also may happen. And then here from this particular lone pair of electron to the next. So again the bond position is changing. Okay. So movement of single electron also can be possible. So it is so pair of electron means the arrow mark is given, curved arrow, or this fish hook kind half-headed curved arrow. It is here represented. Okay, it is half-headed like this, half-headed fish hook like. So this kind of thing is representing the transfer of the electron. The single electron is transferred. Okay. So, for example, transfer of hydroxide ion giving ethanol and in the dissociation of chloromethane, then movement of electron using curved arrows. Here it shows, right? Can able to understand. What is that? Transfer of hydroxide ions. Okay. So where the hydroxide ions? So here, what is happening? The hydroxide ions. Here it is transferred to where it is transfer of hydroxide ion given ethanol. Ethanol is reached, okay? It is given to chloromethane. Or sorry, bromomethane is given. Here it is chloromethane, bromomethane. So you'll be getting alcohol, right? So fish hook arrow is representing one electron is transferred. Okay. From this, one electron is transferred to this group. So that bromine gets detached and then OH is attached. Okay. So this is how the movement of electron is. Okay. Then we'll move on to inductive effect. This is very important effect you have to see in this particular covalent bonding. Okay. You know that covalent bonds are formed between atoms of different electron activity. So the electron density is more. So that also we saw, right? Towards the more electronegative atom. Okay. So that, so such a shift of electron density results in a polar covalent bond. So if total, we saw carbocation and carbanion, right? That also I've explained. So go through this again and again. So then it is easy for you to understand. So polarity exists in, okay? So how the polarity? So we can say, so chloroethane you can take in which C to Cl bond is a polar covalent bond. Okay? Because chlorine is more electronegative when compared to what? Carbon. So it is very important point. Okay. So that is polar bond. Okay. Then I've already told you about this delta plus and delta minus. You should not consider the electron always as a particle. So it is a charge, right? Negative charge. So which consists of 1.6 times 10 power minus 19 coulomb. Out of this, you don't say full charge is transferred from one atom to the other atom. So it might be a fraction of, uh, 80% of this particular charge or 90% of this charge is transferred to the neighboring atom. So we usually call delta plus and delta minus. So delta minus is a fraction of charges are donated. That means the electron is donated to the neighboring atom. So we usually call this kind of polar covalent bond as polarized bond. Okay, so C to Cl is polarized bond. We usually call this kind of process is known as polarization. So carbon 1, where is carbon 1? Here you can situate, see here you can able to demonstrate this. CH3, CH2, Cl. Right. CH2, CH3. What is the first carbon? First carbon gains positive charge, some positive charge. I've told you, no, some fraction of positive charge, and the chlorine, some negative charge. So delta plus and delta minus. Okay, the fractional electronic charges on the two atoms in a polar covalent bond are denoted by the symbol delta, and the shift of electron density is shown by an arrow that points from delta plus to delta minus. Here only the electron is shifted. The arrow mark donates, the electron is shifted. Okay. Is it clear for you? Then, in turn, carbon 1, which has developed partial positive charge, draws some electron density towards it from the adjacent C to C bond also. Since it donates electron, right, in order to maintain its electron density, it draws more electron from the neighboring C to C bond. Now, what will happen here? Delta delta plus is given. Okay. See, delta plus is donated by the carbon 1 atom. Now, this needs to balance its electron density, this carbon 1 atom. So, it again withdraw electron from the neighboring C to C bond. So, now, delta plus is donated. So, it is getting a fraction of delta plus from the CH3 bond. That means C to C bond. So, fraction of delta plus means what is the meaning? Delta of delta plus. Okay. So electron is getting from that particular, next bond also. So like this, the quotient is, so we can say the polarity changes. The polarity is increasing. Okay. In where the electron is shifting from where to where. So the arrow mark also shown in this type of polarization of adjacent sigma bond. This is very important, sigma bond. Adjacent sigma bond is inductive effect. Okay. There are two types of inductive effect. I'll explain you that. Take a note. Okay. So one is plus I effect. So you can put here like this. One is plus I. Another one is minus I. So plus I effect and minus I effect. Okay. Okay. So in this plus I effect column, you can write now. This is inductive effect. Okay. You can write the points. Okay. Here, when electron donating group is attached, when electron donating group, got the point? Electron donating group is attached with a chain of carbon atom. That means you can say C, okay, to C, to C. Here, we can say electron donating group. Okay, so So if it is like that, then what will happen? How the electron is donated? It is the electron donating group. So the arrow mark should be in the reversed manner, right? Got it? So it will be delta plus here, delta plus here, delta minus here, delta of delta minus. Okay? Here, delta of delta minus. Like that, it will go. Okay? So next one. Here, minus A effect means when electron withdrawing group is attached. That's what I said in this example. Electron withdrawing group is attached. What is electron withdrawing group? Chlorine, fluorine, bromine, everything. All halogens. Okay. If the electron withdrawing group is attached, then what will happen? This way. C, C, C. This one is electron withdrawing group. Okay. Then the arrow mark is right side. Is on right side. You know, this will be delta minus. This will be delta plus. Here delta of delta plus. Here delta of delta of delta plus. Got it? Like this, you have to categorize. Okay. I'll give you an example right now. So the example is, so what is a great example? Okay. See, we are going to take the tertiary carbon atom so that it may contains three carbon atom and one withdrawal group, right? C, CH3, okay, CH3, here also CH3, like this, it is what? Tertiary, okay? The plus A effect is more in it, okay, since it is having three carbon atom attached with one carbon. So it is having more plus I effect. Got it? So this is plus I effect, which is greater than here CH3C. It is, we can say, secondary. So this is tertiary, 3 degree, 2 degree, secondary, and then primary. CH3, CH2. Okay. Like this it might be. Got it? Okay. Then CH3. Like this, the plus I effect will be. Is it clear for you? The plus I effect is more in it. Got it? So example for minus A effect. So minus NO2 is greater than minus Cn is greater than. So this is not minus, this is the bond. Bond of NO2, bond of Cn, bond of COOH. Yeah. Okay. Then Cl, you know about this. Right. So since iodine is more in size, atomic size, definitely electron, donating level is increasing due to the decrease of nuclear force of attraction. Nuclear charge is decreasing here. Okay. So based on that, we can able to understand here minus A effect. The order of minus A effect is given. I hope it is clear for you. Then this is all about inductive effect. Okay. We'll see the next one. All examples are given here. Electromagnetic effect we have to see. Electromagnetic effect, resonance effect, I've already explained you. Electromagnetic effect and resonance effect, I've already explained you. Electromagnetic effect, you know, and then resonance or mesomeric effect, we can say. Okay, so I've explained that in another video. Go through it. Now we are going to see the hyperconjunction or conjugation effect. Okay, so hyperconjugation effect. So this is hyperconjugation. It is general stabilizing interaction, that is hyperconjugation. Okay, interaction between, it is a type of interaction between pi electrons and sigma electrons of nearby C2H bond. Okay, this effect is achieved by or achieved when conjugative system is attached with alkyl group. What is the condition you can apply? When conjugative system is attached with alkyl group, Then interaction between pi electrons and sigma electrons of nearby CH bond will happen. So this is hyperconjugation. It is explained here. Okay. You can able to understand this. See what it is given here. C2H bond of an alkyl group directly attached to an atom of unsaturated system or to an atom with an unshared pair electron, p orbital. Okay. So that means that what I said, pi electrons and sigma electrons like that. P orbital means pi electrons, we can say. So it is a permanent effect. Okay. Then this example it shows. Okay. What it shows? Orbital diagram showing hyperconjugation in ethyl cation. See, this is hyperconjugation. Okay. The interaction between pi electrons and this alpha electron with the nearby CH bond. Like this. The types of overlap. Okay. So alpha carbon with hydrogen. So this is alpha carbon. Okay. So I can able to explain this. Okay. So this one, it is alpha carbon with hydrogen, right? Then what will happen here? Uh, so here, after a conjugation, what will happen? Here, C plus, here it will be. This is now shifted here. Okay, the double bond. So double bond, and then here H plus happens. So electron is taken from here. Okay, another bond is formed like this. So these two can be interchangeable. Okay, so here the interaction between the pi bond and the, see here. So carbocation stabilize, the overlap stabilizes the carbocation. So now in the second one, there is no carbocation. So because electron density from the adjacent sigma bond helps in dispersing the positive charge. Okay. So adjacent sigma bond is helping right now. Where is the sigma bond? Here. Okay. This is adjacent. Okay. It is break. So this adjacent bond is helping here to neutralize the cause or stabilize the carbon atom. So, and then here what happens? This may also happen. If this bond also, okay, or this bond also. Like this, it is interacting with the electron density. So adjacent sigma bond. C2H is adjacent sigma bond. So the pi bond and sigma bond electrons are interacting right now. So from here to here, the pi bond and sigma bond. Okay, is it clear for you? Then, so it is also called no bond resonance, or we can say greater the number of conjugative, um, I mean, overlapping is takes place, then what will happen? More its stability will be. So that is the condition. You have to understand this. Okay. And then the molecules that shows hyperconjugative effect must have alpha carbon atom. Okay, with hydrogen. It should have alpha carbon atom with hydrogen. The number of conjugative thing it is going on, right? So that status and then that particular numbers, right? So 1, 2, 3, like this. So it is formed directly related with the number of hydrogen atoms that you know, right? So keep in your mind, this is the hyperconjugation. Very simple. You can able to understand this. See, here also it is happening, right? This bond is balanced. Okay. So it is an orbital diagram it is given. Okay. Overlapping takes place in, see here, sp3 to 1s, hydrogen 1s bond. Right? It is fiber conjugation. 2p is empty now. 2p of this carbon is empty. Okay. See, listen to this. See, hyperconjugation effect. How? So here, ethyl cation. Okay, so this cation and the empty 1p orbital, 2p orbital is empty, and then one of the CH bonds of the methyl group can align in the plane of this empty p orbital. Okay, so it is aligned in plane with empty p orbital. Okay, then and the electrons constituting the CH bond in plane with this p orbital then be delocalized. This electron is delocalized into the empty p orbital. So this is what happening. It is the hyperconjugation. So carbon sp3 bonding to hydrogen 1s bond. Got it? So it is the hyperconjugation we can say. So interaction between alpha electron to pi electrons to alpha electron. Like this. Okay, clear? I hope it is clear for you. Then now we'll try to see some problems or questions what are all discussed. Okay. I'll give you some molecule. You can write the IUPAC name. Got it? So I will give you the molecules. You can write the IUPAC name. Okay. So what is the IUPAC name of? Mm, this one. First one. IUPAC name I want. So the first one. Okay. Right. This. This is double one. Can you name it? How can you name this? Hmm? One carbon atom, two, three, four, five, six. So it is hexane, right now. Where double bond is in the second position. So cis to hexane, right up. Is it clear for you? So what is the transposition? Transposition and cis position you must know. Okay. I'll explain you the transposition. So this is transposition. Suppose if you are given like this. Yeah, this is transposition. So how many carbon atoms? Can you tell me this? Trans to hexane. Clear? So this is cis position, this is transposition. Keep in your mind. Okay. Then you can able to understand some more example I will give you. Suppose if you are given like this. Okay. So can you able to name this? Can you able to name this right now? So how many carbon atoms here? So here one, right? It might be definitely methyl group. Okay. So in the third position, methyl group. One, two, three. Third position, it is methyl group. Right? And then what we can say, where the bond is available, second position. Okay. So we can say one, two, three, four, five. Right? So pentene. So 4, 5 is it is pentene. Double bond is here, right? So second position is double bond. 2 pentene. And then according to the alphabetical order, 3 methyl should come. first, right? So then only pentene will be. Can you able to understand this? That's all. Okay. So it is very clear. You can able to write the IUPAC name. Okay. And then suppose if you are given IUPAC name, you have to draw the structure. Suppose right now I'll be giving you the name. You have to draw the structure. What is the name? 4-propyl hept 2-ine. Like this it is given. How can you draw? Okay. So 4-propyl. So, and then hept to ein. In the second position, to ein is there. Right up. So, how can you draw? Mhm. Second position. Okay. Then, fourth position, there must be propyl. Propyl means 1, 2, 3, 4. So, 1, 2, 3. Right up. So, then, hept. So, 7 should be there. So, can you number now? 1, right? 1, 2, 3, 4, 5, 6, 7. Okay. It is 4-propyl and hept to ein. Ein means this three triple bond. Okay. So like this you have to write. Okay. So I'll give you the homework or assignment. So those who wrote, you can able to send or text me. Okay. So I'll give you the assignment now. Suppose this is a structure. Write the IUPAC name. Okay. So do find the IUPAC name and text in the descriptive box. Message me. Okay. See here, this one I will Google. Okay. Here and here. Okay. Can able to write this IUPAC name and then this is one. And then next one I will give you. Take down this. Next one. 1, 2, 3, 4, 5, 6, 7. So this one, like, okay, it is plural, it is plural. Can you name this? Like, okay. Then suppose if you are given, instead of structural formula, if you are given Cl2, CH, CH2, OH. This also you can able to write the IUPAC name. I hope you can able to understand this and then fourth one and give you the cyclic structure. Okay. So we double bond O, single bond O, C2H5. Okay. Name this. Fifth one. Here CH, CH3, CH5. Name this. Okay. Then sixth one. CH3, CO, CH, CH2, CH2, Cl. Here again CH3. Can you name this and then send it to me? So send us a message. Okay. So and then bond line formula you can able to write. Okay. So I will explain you some bond line formula. For tertiary butyl, um, cyclopentane. Hmm? So tertiary butyl, okay, cyclopentane. See, this butyl should not be start with the capital letter butyl. Sorry, butyl. So this is the question you are asked to find. You are asked to write bond line formula. Okay, cyclopentane. How can you draw cyclopentane? Slightly it is pentane. Okay, then butyl, tertiary butyl. So butyl means you have to draw like this, right? Okay, tertiary butyl. Um, so tertiary butyl cyclopentane. Okay. So what is isopropyl alcohol? Suppose if you are asked to find isopropyl alcohol is this one. That's all. Right here OH. Okay. You can able to write this. Hmm? Then dimethyl butanol if you are given. Dimethyl butanol. Then what will happen? So how can you write the bond line formula? Dimethyl. So butanol. So first position CHO will be there. Second position 2 comma 3 we can write. In the second position and in the first position. Third position. Second and third methyl group is there. So this is the bond line formula, right? 1, 2, 3, 4. Okay. Like this you have to write. Clear? Then we'll discuss some more questions. We can able to write all the formula you pack mail. This is all very easy for you. You must understand. So another questions we'll see. Homolysis and heterolysis cleavage. Okay. So what are all the compounds having homolysis and heterolytic cleavage? I'll share this figure. Okay. So the bond fission is there. You have to find out which type of cleavage is in this particular bond. So shall we do this now? So we are going to do this now. So we are going to see the bond cleavage. Okay. The first bond cleavage you can see here. What is that? CH3, CuCH3. Right up. Okay. And then you know how the cleavage will be. So how it is formed. From this you can able to understand what type of cleavage it is. Yesterday I taught you homolytic or heterolytic, right? Okay. So the curved arrows, what it shows? Electron pairs splitting equally. That is the curved arrow, right? It is splitting equally. So homolytic fission we can say. Two methyl free radicals are given here. CH3 should be there, but it is not given. Okay. Suppose if it is CuCH3, it will be like that. Okay. Suppose if you are given CH3, Cu, CH3. Then it will be heterolytic cleavage. Okay. It gives CH3 minus plus CH3 dot we can say or one electron, one electron. So it is free radical. It is homolytic. But this one is heterolytic, minus and plus, right? It is heterolytic. It is not equal. So here the bond is cleavaged and then it is attached. Since copper is electropositive, it can donate its electron totally to carbon. When compared to copper, carbon is more electronegative. So carbon has minus. Okay, carbon attach both the electrons. So it is heterolytic. Got it? So or we can say it is carbanion. Okay, wow. Then second one, what is given here? Just go through it. What is in this second one? Okay, take down this and let me know what are all the reactions. Hmm? So we'll see the next one. What it is given C6H by O C6H by. It gives two C6H by here one dot. Okay, what type of reaction it is or what type of cleavage it is. So that is the question.